All right, this is section 2.1, and it's called subsets of lines. In chapter 2, we're going to study subsets of lines and subsets of planes. And if you remember what subset is, it's just a portion of the main one. So we're thinking about lines here. Just draw one. You know, it's going to keep going infinitely in both directions. So if we're going to take a subset, it means we're going to take a part of a line. So the parts of a line that we're going to talk about today are going to be called half lines and rays. I could do 10 seconds and explain this to you. It goes into a little bit more detail, but I can give you the hurried part, okay? What you do is if you're going to have a half line or a ray, you have to have a point that is going to break your line up, okay? So otherwise, you're just dealing with the whole thing. So you're going to come up with a point. Let me just draw above. Let's say that this point right here is the one that's going to break my line into pieces. And so we have postulate 2.1, okay, called the line separation postulate. Separation. And what the line separation postulate says is that any point can break up a line into 3 distinct parts. Okay, it's going to be the point itself, and then I'm just going to spread it out a little bit, but you end up with this side and that side. So that's what you want to picture if you would connect these 3 pieces together. You'd be right back here to your line. So if we're going to talk about half lines, the definition of a half line in your book, it says it's the set of all the points on a line that are on the given side of a given point on the line. So this right here is a half line. Okay, and then we have one other definition we have is a ray. And a ray is the union of a half line. Let me go ahead and use this half line because that one's one also. It's the union, which you got to remember what union means. It means put them together. The union of a half line and its point. So I'm going to take these two and I'm going to connect them. Now this one is a ray. So it says definition of a ray is the union of a half line and its point. Things you want to know is a ray will extend infinitely in one direction. So it's just going to keep going. So will the half line. So basically the half line doesn't have an anchor point. It's all of the points that are on one side. The ray has all of those, but it also gets to include the ending point. So we have a little bit of notation that you'll want to know. Let's go ahead and put down a little example problem again. Let's say A, X, T. Alright, so if this is it, let's talk about a half line. So a half line, let's say I want to do this direction. So I do use the A, and I know that it's going in the direction of X. Now I want to show that I don't include the A because half lines never include the point. So you put an open circle and then a direction going that way. So you would call that half line AX. So the difference would be if you want to talk about ray AX, you know, some people put a filled in circle. It doesn't matter. You don't have to put in a solid circle. If you kind of exaggerate that, it would be fine. But you just want to make sure it's filled in. So that's the difference there between a half line and a ray, is one of them includes an endpoint and one of them doesn't. So let me just give you a couple other things that you could see from this line. Now, I could say that I want to do ray XT. So you don't have to put the word ray in front of it. I'm just showing you. XT. So I am including the X so I don't leave an open hole and I go the direction to T. So if I want ray XT, what you want to know is that I would come over here. You should be picturing this point and all these points going that way. That is ray xt. Something else you should know is that xa, since if you were going to use this picture right here, would be the same exact ray, because it starts at x, it includes x, and it goes in the direction of a, which also happens to be the direction of t. So that means that these two right here are the same exact ray because they do go infinitely in one direction. So you can name rays more than one way. The thing that you want to note is that you always want to have your starting point as your first letter. After that, it's just a directional point. Just so if you told somebody else you wanted them to look at ray xt, they would know which direction to go. So you could also talk about, we could talk about half line tx, and it would mean all of the points that are on this side of t. So we would do half line tx like that. And then you should be picturing, okay, it's starting here. I'm not including point T, but I'm including all of the points going towards X. So that's the idea for section 2.1, subsets of lines. It's portions of the lines. So these points that you have right here, those are usually called endpoints. We never want to put, see how I have, let's talk about ray, how about talk about ray AT, okay? It looks in our picture like it's pointing to the left, so, you might have thought, oh, can't you just put the arrow going that way? That is not the proper notation. You always put your arrow going to the right. That's why it is important to have a directional here. So you start at A and then you look at your picture, you want to go towards T. So you kind of have to have them work together to get a real picture of what's happening. But your arrows on the top of your notation are always going to point to the right. So there's a homework or something in your, okay, let's see. Numbers 11 through 17 is a bunch of notation. Let me just give you number 11 real fast. And it says use the figure above exercise 4. So let me just come up with that real fast. So it has A, B, C, and D. That's the figure that you're using. Number 11 says to find A, B, and it looks like it is a half line. And it's got the union symbol. And it has the set with A in it. So what this is saying is half line AB unioned with point A. So half line AB was like this. And if you want to union it with this point right here, you put them together and it turns into that. So it doesn't look like a half line anymore because it does have the included endpoint. So what you would say to this is it's not a half line anymore, it's a ray. That's the kind of stuff they're looking for in numbers 11 through 17. Number 19, list or name 2 physical phenomena that are rays. They're basically saying, can you think of anything that has a starting point and then just goes infinitely in one direction? One of them is the easiest, and I won't say it because then you won't be able to use it. Anyhow, your homework will be 1 through 20 in section 2.1. 1 through 20 all. That's it.